Now, when I look at this problem, looking across the room, it looks like everyone set it up correctly. The biggest difference I'm seeing is a major difference in how many sig figs you reported. So when we look at this problem, I have 3 significant figures here. I have 5 significant figures in this number. And when we start to look at this, we say we want 2% potassium perchlorate. So it's 2.00 grams of potassium perchlorate, KClO4, per 100 grams of solution. Because this is a definition of percent, this 100 grams here is an exact number. This does not count as 1 sig fig. So now I have 185 grams of solution. I have 5 sig figs here, 3 here, and as many as I want in this exact number. So it's correct to report 3.70 grams of potassium perchlorate. And if we look at the back rows board over there, they're the only group that had the sig figs right. Okay? This group truncated to 2. This group went to 1. When you went to 1, were you thinking that the 100 was 1 sig fig? Okay, yeah, you just didn't add those trailing zeros. So do pay attention to that because you know it's going to cost you half a point on the test, right? And if for no other reason, you don't want to lose a half a point on the test. Now, when you leave the testing world of the fake school environment and you go into the real world, it does matter. Jason, you probably see this every day. It matters when you're spreading fertilizer, how much you add, how many sig figs you use. Now, I know you don't go out there with a micrometer when you're putting fertilizer on, but when you start looking at that, it does make a difference. If you're working in the chemical industry and you're looking at discharge information from a plant, it can make a difference how many sig figs you use because you can exceed EPA regulations if you write more sig figs than you're allowed. Okay, so now we have 3.70 grams of potassium chlorate. Figure out how much water we need. 185 grams of solution minus 3.70 grams is equal to 181.30 grams of water is needed. So now we write our instructions. We say weigh 3.70 grams KClO4 into the beaker. Then we add 181.30 grams of water and stir. We could just add water until we get a total mass of 185 also. Okay, do you have any questions on how to do percent calculations? All right, there are some practice problems on this. In the solutions practice, numbers 4 through 9, I am not going to have you do these now in class because I'm starting to feel tremendous stress for getting through the rest of the material for the semester. We really have one more lecture day after today. We'll have a little bit of time on Thursday, but with the quiz, we don't have a huge amount of time to lecture Thursday, and we still have several topics to finish. So do you have any questions? Oh, and Thursday, we are having a tornado drill, and it will be during this class. I think I'll stop the video here before